All right. We made it. Thursday, second class meeting. Very exciting. If you missed Tuesday, that's okay, right? I've got it recorded here. So every session of lecture, I'll record. I don't record the labs because I don't really do a whole lot of talking, and it'd just be really boring to watch nothing. So the lecture sections I'll record. I'll post those out on YouTube and put the links here for you, so you can always come back to it. Again, if you're sick, don't come. If it's snowing and you don't like driving in snow, it's okay. You don't have to come either. I understand that. I'll do my best to be here. Unless it's super bad and they actually close the campus, I should be able to make it. They rarely ever close the campus, though. I think it's happened once in the last 7-8 years that I know of. I don't know. And it was a big deal when Ann Arbor closed, and everyone made fun of the new president because he's like, we never close. And then they're like, oh, no, wait, the Michigan News said you did close at one point. He's like, oh, yeah, my bad, which was nice. Like, you should be able to admit when you make mistakes, and that's okay to do that. I will make many mistakes in front of you, I promise. I will pretend they're on purpose. They won't always be. Occasionally, I might try and make one on purpose just to illustrate, hey, this is what happens when things don't go right. But most of the time, it's when you're working in code and things don't work right, you have to go figure out why it doesn't work right. That's part of the process, and that's okay. So we'll get into that. So again, we're a little bit ahead, which is great. We can start talking more about objects and classes. We'll spend a little bit of time talking about Unix. Because our lab sessions are Tuesdays after we do our lecture time, it's a little bit weird for the format here. So I'm actually going to wait and show you what you'll do in the Unix lab on next Tuesday, because then it'll hopefully be somewhat fresher for when you do it Tuesday afternoon. I won't do that for most labs, but the Unix lab is special. And you have probably never worked in Unix before, or maybe ever in the command line, and that's okay. You'll get there eventually. It's a great, powerful tool. You can do lots of cool stuff with it, or terminal if you're on Macs. So I'll show you what we'll do for that. It'll go pretty well. But that'll probably be the last time I show you, hey, this is how you do the lab. After that, the lab is, here's a practice to do something we've talked about in lecture time. You go practice it now. And again, during lab time, I'll help you. I'll wander around the room and make sure you can get it done, right? Ideally before you walk out. If you want to wait, that's okay. Or if, whatever happens, it'll be due the next week after. Try not to get into the habit of getting behind. I've had people occasionally they're like, oh, the lab isn't due until the next week, so they're always working on last week's lab in this week. And it's your time. You can manage it however you want. But if you're not keeping up with the lab work, then when you go to do the projects, you haven't practiced the stuff that you needed to have practiced to be able to be successful on the projects. So that sort of thing here. So after we get through objects and classes and exceptions and pointers, we'll start our first individual project. So that'll probably be Tuesday the 23rd is the plan for that. So we'll have enough time to get some stuff under our belts here. Objects and classes will start as a refresher, hopefully, from 150, things we've talked about, build some classes out, work with objects, and then getting into using exceptions and pointers. I'm a big fan of exceptions. I think that's the right way to write object-oriented code. We'll talk about that. I have very strong opinions about things. Other people have other strong opinions about other things, and that's okay. So we'll figure that out as we go. So that's chapters 6, 7, and 8 we'll get into along with Unix. And that'll be essentially the topic for the first project, not the Unix piece here, but objects, classes, exceptions, and pointers for that project 0 that we'll get into. Right? And then we'll just sort of pick things up as we go. The flow should work pretty well for us. Not super concerned with the lab being in the middle. Most of the stuff we can get through, I can intro the topic, you can practice some of it, and then we can finish up talking about the topic on Thursday afterwards. And that should go pretty well for us. So. All right, so I got Visual Studio here. I badly named Hello World. I thought it would just be our Hello World example here, right? But we did our quick little, oh no, I didn't. Did I leave this one here? The lab. Did I put it all in lab? I'm having trouble remembering what we did on Tuesday already. 9:30 in the morning is not my preferred time. I actually got into computers specifically so I wouldn't have to be up at this time of the day. Most days of the week, I'm up at like noon. And that's what I like to do because I'm up till 4 in the morning. So 4 in the morning and then getting up at 7 to get ready for class is no fun. Hence the original Stanley mug thermos here, not the new crazy popular one. I didn't have to knock people over at Target for this one. So I've got that to keep me going. I don't know if I mentioned, I tell a lot of stories. I apologize. So if you've heard it before, just tell me to skip it. You're not going to hurt my feelings at all. I'll be like, Eric, you already told us, because sometimes I forget. This just happens. So at the end of every semester, you get those notifications in Canvas. Hey, do the end of semester eval. Do the end of semester eval. Do the end of semester eval. Please do those. It's part of our review process. And it turns out most people who want to review things, including their instructors, were either very happy or pissed off. If you're like, it was fine, it was a class, you probably aren't going to take the time to do the end of semester survey. So the results get very skewed. I get people who are pissed at me, and I get people who are like, Eric was amazing because he helped me all the time. Which is great. I like helping people. That's fine. And that looks good on my evaluation. My poor department chair has to read all these things, or is supposed to read all of these things. I can't promise he does, but it does go to him in the review process and the review committee, and we've got all sorts of lovely things in academia for reviewing things. But yeah.
Is the review process done after each semester?
No. So the lecturers are covered under a collective bargaining agreement. We're in a union, so we have a union process for how reviews are done at certain milestones and every X number of years based on how. There's like 3 pages in the contract about reviews. If you're bored, you can go view it on our website. Tenure track faculty have a different review process. So anyone who has the title professor has a separate review process. They're not a part of the union, but different departments have their own process for how they review professors. For generally, it's the promotion reviews. So you go from assistant to associate to full professor, and they have their whole suite of things they have to do to get those different ranks and get promoted and all sorts of fun stuff. So tends to be why, again, a little bit of an off topic here, but it's a fun fact. The lecturer faculty, we're paid to teach. That's what we do. We get paid to teach classes, and we teach somewhere around half the classes or half the credits on campus here. I don't know the exact split right now. The tenure track faculty are paid to bring in research money. This is the officially accepted thing. They're supposed to be publishing research, bringing in research grants, doing that sort of thing. They have to teach on the side. There's a minimum required number of credits they have to teach each year, and they can actually bring that down by having more research money. They're like, hey, you're doing a really good job with your research, you're really busy with your research lab, you got a bunch of PhD students, you don't have to teach as much, which is great. So it's a weird system. So I enjoy teaching, I like doing that. I had a small sampling of getting to do some research before I had to drop out of my doctoral program due to some family health issues, and research is hard work. It really is very time-consuming work. So I can understand why they need more free time to do that stuff that's hard and difficult, and they have specialties in their fields and all sorts of fun stuff there. But reviews, yes, please do them. One of my reviews, because you can leave comments and it's anonymous, which is great, so you can say whatever you want, which is great. Someone said, Eric is like a squirrel with an adrenaline shot. I'm a little bit embarrassed by that, but also a little bit proud of that comment. So I like telling that story here. So just holler at me, because I drink a lot of coffee to keep myself awake at weird times here. My schedule this semester is lovely, which is great. Dr. Zhu, our department chair, was very helpful, so I didn't have to drive here 4 days a week, just 2 days a week. I'm here from 9:30 in the morning till basically 9 at night on Thursdays with different classes. So I will have lots of coffee all the time, and I'm working on talking a little slower. Please just holler at me. You're not going to hurt my feelings. You don't even need to raise your hand. Just be like, Eric, slow down, right? You're going to do everyone a favor, because if you feel like it's too fast, the person next to you or in front of you or behind you also thinks it's too fast, okay? So that's really okay. The goal here is that I'm helping you work through the material, learn the material, giving you examples, that sort of fun stuff here. If you just let me talk and you lost me half an hour ago, I'm not doing a very good job. But it's hard to know sometimes. I can look around and I can see the blank looks on your faces occasionally. I'll be like, oh wait, I probably have to go back. Sometimes I miss that, right? Or sometimes half the people are like, yeah, this is great, and other people are like, I don't know what they're doing anymore. So you gotta let me know. So the lecture time is my chance to go over examples and talk about things. If you got questions, bring your questions. That's fantastic. I love answering questions. It makes it much more interesting if you folks spend some time talking, because believe it or not, I do actually get bored of my own voice. I do talk a lot, but it is really boring to be the only one talking for a very long period of time. Okay. You all right so far?
Yeah.
All right, cool. So let's go make a new project here. Again, I'm going to be putting all the code examples in the course repository. So that is linked out here in Canvas. So if you ever want the code I do in class, you're welcome to type along, or you're welcome to watch the video and type along. I don't recommend that because good developers are lazy. And having to type something that you can just go copy paste is the opposite of lazy, right? You've done more work than you've needed. So go to this course repository link here, and it will launch the GitHub site here, and they'll be by project, right? Because this is essentially a file viewer here. You can find Hello World. This was boring here, but I'll try and name them nicely by week if I remember. If I name them by week, it's really easy to go back and see what happened each week, and then it's sorted alphabetically really nicely. You can go see the code, right? Just click in here, click in the next folder, find the CPP files, the H files, all the stuff we build, and you can see the code. From here, you can copy paste. You can clone this repository. I don't actually recommend that because I'm changing it every week. So then you have to make sure it stays in sync. And then if you make changes, you can't actually commit those changes because you don't have access to commit to this repository. You have access to view it. And it's a whole fun thing. So Git does really cool, lots of amazing stuff. We're just kind of scratching the surface of it. But this is a great place. So you don't even have to download files out of Canvas because that is awful, right? Code does not belong in Canvas, and that's a hill I'll die on. So anyway, let me start up a new project. We'll do a console app. Let's call this week 1. This is classes. And then I got to make sure I put it in the right folder, right? The idea here with repositories is they're just a folder. It's all it is. It's a folder that the Git source control tool watches. And it watches to see, hey, what's new? That's all it does. So right now in my GitHub client, there's nothing new in this folder, right? The state of the folder, the last time I took a snapshot, that commit here, nothing's changed since. This is my Hello World snapshot, right? This is the one I took. So commits are just snapshots. It's what did the files look like at this point in time, right? And it builds up this history, which is super cool. And if projects that live for a long time, you get that amazing history. You can see, hey, it's been changed 1,000 times, and you can go back as far as you want, and all sorts of good stuff there. It's great. But right now, nothing's changed. So as soon as I make my project in this folder, right, and I know it's this folder, if you don't remember where it is, you can say Show in Explorer, and it will show you the path up here. Right? It's in my users, documents, GitHub, whatever. You can put it anywhere you want. As long as you put your project in that folder, Git will be able to say, hey, there's something new here. If you don't put it in that folder, Git has no idea that there's something new there because there's not anything new there. It's not there. Okay? You can always go move it after the fact. You can make your project and then cut and paste it. Perfectly fine. That's okay too. But then you've done more work than you've needed. Again, aim to be lazy, right? Be a good lazy person. So make this one. This is week 1 classes, and we'll create. And again, I'm just going to get rid of all these comments. I really should take that out of the template here, but I've, again, have not gotten to that. Now I come back to GitHub, and it says, hey, there's new stuff here, right? There's the solution file, there's the CPP file, my project file, the filters file. Great, good stuff here. It sees new things. So new things show up as green, a little green plus, this is new. Red minuses are removed, and yellow dots are changed. So we'll get to the yellow dots in a little bit. We haven't changed anything very interesting yet. And then you can make as many commits as you want. Again, these are free. It costs electricity, but we don't have to pay for that, thankfully. So essentially free, right, when we commit here. So here's my project started. You're welcome to make commits if you want. Depending on your preference. Some people like committing every hour. Some people like committing every time they've done a significant amount of work. Some people like to commit every time they get up from their desk. Whatever you're comfortable with, go for it, right? The commits are free, go for it. So I've committed. Now my local repository has that changed. Did I already hit push? Did I do that without even thinking?
Yes.
I did. I was supposed to pause there. So the next button that I clicked without even thinking, because it's just habit, here's push. Push will go and synchronize my changes with the cloud. Right? Git is this distributed source control tool. Everyone has the copy of the repository. But to get my copy, get the changes there out to the central copy, I have to push the changes out. If something changes on the central copy, I have to pull those changes back down. So it's a push and a pull. So you push changes out, you pull changes down. So it also works with teams, right? Teams can collaborate on code because they will push their changes and pull the changes down. It works great. And Git is good enough that it looks at things at the line level. So if you're working on a 500-line file, because this is a slightly interesting project here, and you change line 427, and someone else changes line 123. Git will figure it out. It's like, okay, cool, I'll make that change, and you make this change, and it knows to slot them in the right place. If you both change line 427, it gets confused, because it doesn't know which one. And then you have to go tell it, I want my line 427 or I want their line 427. But if you both don't change the same line, it figures it out pretty well. Again, it does all sorts of amazing things. There's a whole series of videos you can watch on Git and do amazing things. For now, it'll be really easy because you're the only one touching the repositories. I'm not going to change your code. If it's just one person working on it, it's easy. You're not going to run into any issues where two different people change the same file, because I don't think you're two different people. Okay, works out pretty well. So commit and push, and then again, you can view it on GitHub, and then you can see your code out here. If you can see it on GitHub, I'll be able to see it on GitHub. Again, the one caveat there, make sure it has my name on it. So when you're doing all your assignments, the URL will say Charnesky. You can go make your own repositories, and if you make them private, I don't have access to them. And if I can't see them, it's hard for me to score them. Right? So just make sure you're using mine. The links that you have for all the labs, the links that you'll have for the projects, the classroom.github.com links will automatically give me access to them. That's why I use them, right? Because it's easy for me. I give you a link, it makes repositories. Life is good. It goes pretty well. All right, but now we can get started. Again, so I like the using namespace, space standard. Again, less typing is always happy for me, but not too big of a deal one way or the other. And we probably don't even need hello world. We can get rid of that. So if we wanted to write a class, this idea of writing a class, so working with objects, doing object-oriented programming, there's not really anything you can't do without objects that you can do with objects. It's not required for programming. We like using object-oriented programming because it's a natural way for programmers to think about code and think about how things interact, right? When I talk about chairs, you all know what a chair is, because that's an object, it's a thing, right? It's a noun. So generally our classes tend to be nouns. Some crazy other examples, you get some interesting, weird things that aren't really necessarily nouns, but in general, we work with nouns, right? And nouns have a bunch of attributes, right? You think of, hey, this chair, it has a color, it has a number of wheels, it has, the height of the chair. Any sort of attribute of chair, any way that you could describe chair could be an attribute of that class. It doesn't have to be, but it could be, right? As many things as we need to put in our code to model a chair, we can make as attributes in our class, right? And following our good procedures with object-oriented programming, we're going to do these fancy terms. We're going to encapsulate all those details into one nice little package. We're going to hide our attributes, have private attributes, and give public functions for people to interact with our class. That's the idea of abstraction, another one of our fancy technical terms, right? So if we work with things abstractly, all we need to know is that there are public functions, right? When you did random numbers, right? We did random numbers in 150 a bunch because random numbers are much more fun because your program looks like it's new every time, right? Random numbers. Okay, cool. A couple of people are nodding their head. It's still really early. I've got coffee if you want it. So you don't actually know how the random function works, do you? I mean, I don't actually know how it works. We could go look up the code, thankfully, because we can, but we don't care how it works. We just care that if I ask for a random number, it gives me one, right? We'll work with it in this abstract sense that I don't need to know the details. I just need to know it does what it's advertised. The same thing works with our classes. So when I build a class and I write public functions, people using my class, because I wrote such amazing software, everyone wants to use my class here, know that it will do what it says it's going to do. They don't need to care about the details, right? We've encapsulated all those details in one nice little package. They work with it abstractly. They get, here's the public functions you get to use, and then they're happy, right? When we use the standard library, as we're going to use all throughout here because the standard library is amazing, really smart people have worked on it, much smarter than I am, and they've made sure it's fast and good and does all the things it needs to do. We don't need to know how the standard library works to be able to use it, right? We will spend a ridiculous amount of time building some of these things that are already built in the standard library so you can appreciate how good they are and how they perform the way they do, because understanding performance is a good thing, right? And that's one of the science-y sort of things about programming, right? Making sure it performs well and is fast and efficient. That's very science-y. That's less the art of solving problems. So we'll get into that sort of stuff. But if we wanted to write a class, sorry, I keep getting distracted here. So let's make a class. So we'll have a class for chair, right? Because chair is very exciting. We're gonna have our private section and we're gonna have our public section, right? Oops, I'm using the wrong syntax here, sorry. I get mixed up occasionally. There you go. So things about chair, right? And we probably are going to use strings here because strings are easy. So we're going to include string. So chair probably has a string for color. Is that, yeah, string for color, right? We probably know what color the chair is, right? It probably has, now when we talk about height, we could use integers, we could use doubles. It's totally up to us. Double probably is the easiest to use, and it's unlikely that we're going to have millions of chairs in memory, that it will really matter that doubles are bigger than integers. Again, being memory efficient is nice and good. At our level right now, we don't have to optimize anything. We're not going to do anything at a scale where our optimizations will have any impact whatsoever, right? We don't care. Later, we won't have that luxury. So it's nice to talk about now, but sure, I'm just going to call it a double here. So here's my height. Now, when we're measuring things that have units, I will strongly always recommend you should put the unit in your variable name. Because if I just say height, most of you will probably give me a height in inches because we use a terrible measurement system here in America. Inches is the worst system out there. Well, we should be using the metric system. And if we'd like to use the metric system, we should tell people this is the height in meters, right? So they know just by looking at the variable name, this height is measured in meters. It's explicitly here in the code. If you have to have height and then put in a comment, say height is in meters, you've done a bad thing here, right? This is a stupid comment. Please don't do this, right? Just name your variable name. Now it's height in meters, okay? So I know this is my height in meters, right? So we've got color, we've got height. Now maybe we even have a Boolean value for has wheels, right? This is a true or false. It's a yes or no. You have wheels or you don't have wheels, right? Thankfully, I think our chairs seem to have wheels, which are really nice. They make a big difference in chairs. Wheels are great. A fun fact about wheels. This is just a bonus fun fact. Someone was doing a talk, I forget who it was, about the idea of inventing things and ideas, and it can feel a little overwhelming to feel like, hey, can I really make an impact in the world and come up with something that no one else has thought of before? And do you all remember, you're a little young, but it's okay, you probably remember when the first time we landed people on the moon was. Do you remember what year that was? 1969. So that was, wow, I can't math fast, 40, 50, 55 years ago or so, right? Yeah. About 55 years ago or so, we were able to land someone on the moon. Crazy, amazing technology. There's some, I should really know her name. There's a picture of her, she's famous, next to a giant stack of paper, the amount of code it took to do these sort of things. Oh, what's her name? Yeah, she's in the movie. Apologize, some things are in my head, some things aren't in my head, but we can Google her, she's awesome. Anyway, so we landed on the moon 55 some odd years ago. Have you guys ever traveled at an airport and had to have like luggage with you? Does your luggage have wheels? Yeah, because those things are heavy, right? Do you know how many years ago someone invented or thought of the idea of putting wheels on luggage? Less than 55 years ago. So we were able to send people to the moon before someone had the idea of putting wheels on your luggage. So I promise you, there are still ideas out there that people just haven't thought of yet. And that was the idea of the talk. Like, don't be discouraged. Like, there are so many good ideas out there that people just haven't had yet. There's still room for improvement. There's still room for awesome stuff here. So we'll get there. And that's your fun fact about wheels for the day. What is the date of that? Date wheels were added to luggage. 1970. Not very far after, right? But still, astronauts had to carry luggage by hand because they didn't have wheels on their luggage when they were astronauts going to the moon. Just, I don't know. Okay, that sort of fun fact is very interesting. So we've got private attributes, right? And now we're going to give public functions, okay? So the idea with our public functions is this is how someone can go and access our variables. You don't generally want to have your variables be public because then people can go change them. Now, it seems a little silly at some point here, and that's okay, we can admit this is a little bit silly. If I just make a set method and a get method, and I just take a string for color, and I just give you back color, you've essentially made a public variable. And it feels like doing a lot of extra work to make it private and give me public functions. Yes, that's true. But the good thing that we can do here is we can start adding some sort of constraints. That's where we really get value out of doing this here. So do I have it here? I don't. My goodness. I get confused sometimes about which tools do all the fancy work for me here. So occasionally I have to write these by hand, and it makes me sad. There's tools that will generate set and get methods for you. They're fantastic because they're really tedious to write here, but that's okay. So we'll have color. So we'll say, hey, this is a void get color. Set color function here. To set the color, you need to give me a string for color, right? Now, again, I'm just going to put all of these in line in my class here. That's not necessarily the best form. There's all sorts of interesting things about when you compile code, where the code actually is and how it gets compiled and linked. And I don't care right now. This is 200, right? I'm going to do the easy thing for you. It's not the best way. It's better to separate out all your files so that when things get compiled and linked, they don't have to regenerate code. None of our projects are that big, right? When you get into large enterprise software, if you have to recompile when you hit build every single function every single time, even if it's never changed, you've wasted a lot of time, right? For us, it adds like a couple milliseconds. We're never going to notice. So if someone tells you you should always put your things in H files and separate CPP files for implementation, just smile and nod. Great. I won't ask you to do that. Okay, that's fine. I'm not going to ask. Okay, but you might see it look different. So that's why I put them here, just a little caveat here. It's not the only way to do it. If you'd like to see the other ways, I'm happy to spend the time and show you the other ways, or you can take a look at Zybooks. It has a whole section on where you put your functions and things like that. So anyway, for set color. Now, again, I'm fond of using the variable name as my argument name here. You can call this C if you want, and I'm going to say you're stupid, right? Again, it's not useful to say C here, because when you go use set color somewhere else, it's going to come up with C instead of color, and you're going to be confused, right? So I can make a chair, Eric's chair, and I can say Eric's chair dot set color, and when I give it set color, it says, hey, it wants a string C. Now, you probably know C is probably for color. This is rather obvious, not the hardest thing in the world, but if I spell out color here, when I go use my function, right, the IntelliSense I get now says, give me a string for color, and this is just much more obvious here. Makes the code a little easier to read, easier to use. Okay, it's just a style, just a preference here. The code will work one way or the other. It doesn't matter, right? We can put A's and B's and C's in our code instead of real words, and the code will still run. C++ doesn't care if you can read it or not. The people who care if you read it or not are you, because you're going to forget what you wrote an hour later, or when you take a nap and wake up the next day, you won't remember what A, B, and C mean, right? I won't know what you mean by it. Your classmates won't know what you mean by it, and later on, when you work in the industry, I think we talked a little bit about this software development lifecycle, the idea that software is expensive to write. Did I talk about that on Tuesday? Right? You get paid a lot of money as a developer. That's hopefully why you're getting into the field, right? Make a bunch of money. It's a good field, promise. I shouldn't promise. I'm sorry. It's not a good field for everyone. Generally, it's a pretty good field. I shouldn't promise things I can't commit to. But because it's so expensive, companies want to get their return on investment. Right? They spent a bunch of money to pay developers to write software. They want to use the software to save the money or make them money or make them more efficient to fire other people or whatever the process happens to be, right? However, they're going to get more dollars out of it. The longer they can do that, the more money they make off their investment. So software mostly lives in a state called maintenance, where we're maintaining the software. You don't always have to patch things and fix things and keep things up to date, but if you notice, most of our software updates itself. Right? That's a relatively common thing nowadays. Hey, this needs an update. This needs an update. This needs an update. Right? That's the maintenance phase. So maintaining software is a big part of the software lifecycle. And as you've worked at a company and you've done really cool things, you wrote really cool software, you've probably moved on to bigger and better and other things. You probably aren't going to be writing a piece of software and maintaining it for 40 years before you have enough money to retire. I hope so. Right? I hope you go do interesting things. So someone else will maintain the code that you wrote. Okay? The odds of the person who has to maintain your software being a psychopath are not zero. They're not very high, but they're not zero, right? So you want to make good code that's easy to maintain so that if you happen to get a psychopath who replaces you, they're not going to come after you. It's a terrible joke, I apologize. Usually people laugh, but it's like 10 in the morning right now, so maybe it wasn't as funny here. It's okay. So good variable names make our code more maintainable. Right? When we looked at our course outcomes, that's actually one of the outcomes here, having good, easily maintainable code, easily modifiable code. Using good variable names, believe it or not, is part of that, because we know what these variable names are. All right, all of that to set color. We'll get there eventually. We're cruising here. This is why we started early. It's okay. Right? So to set my color here, right? Now, because I have two variable names named color, I have my private attribute color and I have my argument color here. I can't say color equals color. this is really confusing, right? And you'll notice you do get a little bit of hints here from Visual Studio. This is gray, and it says parameter color. This one is white, but it also says parameter color. So I'm really setting the parameter you gave me to the parameter you gave me. I've not touched my private attribute, right? Do you remember the keyword we have to use to access our private attribute? It's really early to ask this, I'm sorry. It's the word this. Word this. We have the this pointer. We say this. So this arrow color. So this is the implicit pointer to the object you're working on. So when I say Eric's chair.setColor, and I'll say, hey, my chair is blue here, when this code is running here, this is Eric's chair. Bless you, right? Because that's the chair I called the method setColor on, or the function setColor on. If I make another chair, if I make a chair for Jeb's chair, and I say Jeb's chair.setColor, Jeb's chair is red here, this, while this function is running, is Jeb's chair. Right? It's the object that you've called the function on. It's the implicit object here. Right? This is what's great about objects. I can make the class here, that's the blueprint. This is what the object looks like. Here's all of its attributes here. And then I can make as many of them as I want in memory. I could make 30 chairs in this room here, and we could have them all be unique chairs for you. Now, they're not all unique chairs, but they could be, right? Or we could put them in memory. We could do fun things with them, and we could take the wheels off of some of your chairs. We could change the height of some of your chair. We could do all sorts of fun things if we wanted in our code. But this is saying this is the object that you called this function on. So this arrow color now is my field color. So field, right, is this idea, this is my class level attribute. It's a field color, not the parameter color. And now the gray and white makes a little bit more sense here. So we see white is my variable here, the gray is the argument here. You're trying to give some hints here, okay? So that's our get set color. And again, now if we have a string function, so this is going to return something, right? Voids don't return anything. My string get color just returns color. I don't need to use this because I don't have two things named color. It knows color is the field. You can put the this in there if you want. It won't hurt anything, but you've had to type more than you needed to. It's okay. No one will care except for you. It's good practice for your fingers, right? Yeah, everyone wants to be a faster typer. Which, if you're bored sometime, we can play Type Racer. It's a fun little online type challenge game. I rarely lose to students. I think I've had like one person beat me in the 10 years, 11 years I've been challenging people to it, because turns out when you start typing at 5 years old, you get decent at it. And I actually learned typing on a keyboard, not on my mobile phone, like a lot of folks have learned now who have really fast thumbs. I'm better on a keyboard than I am on my mobile phone. You guys can probably out-type me on phones. I wouldn't wager money that I could out-type you on phones, but I would probably bet I could out-type you on a keyboard. Okay. Anyway, so our gets and sets, accessor and mutator. Right? That's our fun terms for these. You access the value or you mutate the value. Now, just taking a color, I've done no bounds checking here. I don't care what you gave me. I'm assuming you gave me something good. If we wanted to, we could have a list of here's the possible colors you could set for a chair. I don't care to list out all the possible colors for a chair. It's not very useful for meaningful. Now, if we were selling chairs, I might want to restrict the colors that you can set a chair to be in my software to make sure that when you ask for a chair of a certain color, it's one that I can make for you. Customers get unhappy when they order things and they don't get what they ordered, right? It happens to me all the time. When I order my coffee with soy milk, because I don't do well with dairy anymore, getting old sucks, by the way, if I get actual milk in there, I'm unhappy, okay? Right? You want to get what you ordered. So putting some bounds checking in would be useful if it matters to our application. If it doesn't matter to our application, don't waste your time, right? If we don't care what the color is, we don't care. So things that probably do matter though, like the height in meters, right? Height in meters, turns out height has to obey the laws of physics, right? I've never met a chair or seen a chair with a negative height. Right? That's just a hole in the ground at that point. That's not a chair, right? You've dug yourself a hole. So when we have methods for set height here, given a double for height. Now, if I just say my this height, height in meters. Oh, there we go. Height in meters. There we go. Set height in meters here. I got to name these nice here, right? We should include that everywhere. because people will forget. And occasionally we've crashed rockets because the rest of the world uses metric and we're still stuck on our stupid measurement system because Congress failed to act in 1970 when we had momentum to change the metric system in the US. Anyway, other fun facts there. So this height in meters is my height in meters, right? If all I do is take, did I misspell it? I didn't misspell it, did I? It should turn gray there, I'm confused. Parameter, okay, it's got the parameter, I don't know why I didn't turn gray. Sometimes Visual Studio gets a little confused. It might fix it later. So if all I do is accept it here, I might now have an illegal chair, an impossible chair that doesn't follow the laws of physics. One of the reasons we like object-oriented programming, we like writing classes, we like this idea of encapsulation and hiding all of our details away, is we get to protect the integrity of our class. If it's important to our class to have a certain bound or range for a value, put that in your code. That's why we have these public functions here. If I didn't care what you set height to, I could make the value public, and people could go change it. If it's public, people can change it to a negative value, and now my chairs don't work anymore. Right? So I can add some checking here and say, hey, if my height in meters is less than 0, right? Well, this is no good. I don't want to do that. Now, we've got lots of options. We'll talk about exceptions next week or the week after, right? Because we're a little bit ahead. Whenever we get to it. We'll get to it soon. We'll talk about exceptions. Exceptions is the right thing to do. We just haven't got there yet. So, to do, come on, figure out exceptions. But for now, we can just say, hey, let's take my height in meters, set it to 0. So you can have a chair at ground level. It's a cushion at that point, right? We can call it a chair if you want, but it's a cushion. Right? If it's on the ground, if it's height 0, it's probably okay. But you can't have negative, because then you have to carry around a hole in the ground. You can't carry around a hole. You can dig a hole, but you can't take it with you, right? So if it's less than 0, set it to 0. Then we'll go set it here. Now, again, I'm fond of doing less work than I need to. I don't need an else here because I'm changing the attribute, the argument here to 0, and then I'm going to go set it to the argument. That's perfectly fine. If you like the other style here, you can go the other style. You can say, hey, if my height is 0, set my this height to 0. Otherwise, go set my height to this. Right? You see how it's functionally the same thing here? Where if do this, set it to 0, otherwise do this. We just saved the else by saying if it's less than 0, put it to 0 before you set it. So again, I'm fond of this style here. There's a school of thought that says the less indentation, the better. Right? The more code that you have indented, the harder it's going to be to read, especially when you get like 4, 5, 6, 7 levels in indented. It's just really hard to follow, right? And Visual Studio is nice, right? You get these nice little dashes here that kind of line things up for you. And if you're bad at lining things up, that's okay, right? It doesn't hurt anything. You can put things anywhere you want here. And you go to the, oh my goodness, where is it? The edit menu here, and you go to advanced, and you go to format file. Where is it? Format document, or usually document. So Control E and then D will format the document for you, and it will align everything for you. It's an amazing shortcut. Please don't do this by hand. It's a giant waste of time, right? Just Control E and D, or go back to the menu, go click if you like clicking things. Some people like to think that they're better if they never take their hands off the keyboard. You're probably more efficient if you don't take your hands off the keyboard. I don't think you're better, you're just more efficient. And then we can debate whether or not that's actually better or not. But anything you can do in Visual Studio, there's a keyboard shortcut for it, so you don't have to use the mouse. Like, it's written by developers for developers who are lazy or want to be efficiently lazy. So everything you can do without taking your hands off the keyboard, so you can keep typing. I like the mouse, though. I use the mouse a lot, yeah.
When would you want to use the formatting? Because isn't it already formatted?
It is now, but like if you didn't do this right, or you like had a bunch of stuff in weird places here, and like this was tabbed in, and like this one is down a bunch of lines, or hang on, like dropped one, like you can do some weird stuff here. It's E and then D. Control E, Control D. It'll fix it for you. It doesn't fix quite everything here, right? Like it doesn't really know what to do with comments, but generally it will line things for you. Nice. And so as we're working with large files, it works out well. Now, if you're missing curly braces, it doesn't format very well because it doesn't know where to put things because things didn't line up right. So if you've got errors like, hey, you're expecting a curly brace, which is weird, it says down at line 51 it's expecting a curly brace because I took it out of line 38 here. Again, it's not perfect, but I was missing it here. We can go fix that later. So generally that's when you have to follow all these like dashed lines here. Just kind of look at where is it lining up. Does it line up visually here for us? And again, the tabs, right, as you learned last semester, right, are for people. C++ does not care about tabs, doesn't care about white space, right? You can do this program all on one line. Please do not do that. Well, okay, these ones you can't, but everything else you can do on one line. Please don't do that. It's really ugly, really awful, and I will be upset just looking at it. Okay, I try not to get upset by stupid things like that, but things just irritate me sometimes. I apologize. Anyway, so either direction here is perfectly fine. If you wanted to set a maximum height for your chair, right? You can't have chairs larger than 5 meters. I don't know. We could set rules like that. We could put bounds checking in. So the reason we have classes, the reason we have public functions that access our private variables is so we can maintain the integrity of the class. If this is the valid range, make sure that's the valid range. Don't let someone take it out of valid range. We wrote the code. We have control over that. So whatever makes sense for us, we can put into code. And again, it's whatever problem we're solving. If it matters to solving that problem, we put it in the code. If it doesn't matter to solving that problem, like the color, if you want a fuchsia chair, go for it. Have a fuchsia chair. No one cares, right? That's fine. You can take any string you want. So that's set get, and then we have the wheels, the last one here. So we'll have a void for set has wheels, and this is a Boolean value for has wheels, right? This is just a true or false, and we'll have this has wheels is my has wheels argument. You know tab does the autocomplete, right? I hope you saw that last semester. Okay. I make extensive use of tab all the time, so it looks like I'm typing way faster than I type here. But as soon as it pops something up, you can arrow up and down to pick which one you want, and you hit tab and it autocompletes. That's super helpful here. And that's for Boolean for get has wheels. We'll just return. So like, I don't want hash here. So I'm going to arrow down one to has wheels, then I'll tab to autocomplete it. Right, so make use of that. And that's why I always roll my eyes when people are like, oh, long variable names take too long to type. If you're typing out your variable names, you've done it wrong, right? You type a couple letters and you hit tab, the computer types it for you. So long variable names don't slow you down at all, right? They make everything better for nice long variable names. I think the longest variable name I ever had was like 180 characters, and I was kind of impressed with it, but it was a dumb thing. You can put comments in to say, hey, you know, I am doing this for a particular reason here. Or you can make your variable name ridiculously long, like this has the value here because it gets forgotten in this other step. I don't know if that's actually the best thing to do, but I was amused by it, and everyone else liked it. They're like, oh, sure, that's a great variable name. I was like, okay, cool. And you can do fun things with it. So this is our really boring chair class here now. But we can set and get color, we can set and get height in meters within bounds of it being positive, and we can set and get whether or not we have wheels, right? Now, you might have heard of this idea of preconditions and postconditions in 150. Generally, we talk about it in 200. Sometimes people mention it in 150. It's a really fancy technical term for this is what's true before, and this is what's true after. That's the entire thing. It's really dull. Some people love putting that in comments. Again, I'm not going to ask you for comments because you don't need them. If someone else asks you for comments, you put them in. You just smile and nod. It's okay. I won't ask you for them. But to say this is what's true before and this is what's true after, a post condition of set height in meters is that height will be at least 0, right? This will be true after you run this function. It will be 0 or more, because that's what the code does, right? There is no possible way to set your height to less than 0 in our code here, or there shouldn't be, right? Because we wrote the code to make it not happen. So that's a post condition. Most of these things don't really have preconditions at this point because nothing has to exist beforehand. Later, when our objects get more interesting, we get more interesting classes, we'll have preconditions. Like something must be true before you can do this next thing. That's all that is. So we'll talk about those when we get there. So now we've got our chair. Now, chair, though, is a little bit obnoxious to use because I have to go and set a bunch of things here. Set has wheels to true, and then Eric's chair dot set height in meters is probably, I'm at like 1.5 maybe? No, that's really high. Maybe like 0.9? Maybe not even point. I don't know. I'm bad at this sort of thing. It's not half as tall as me, right? So maybe 0.7? It doesn't matter, sorry. Not important. So set it to some value. So having to say set and set and set is a little bit tedious. Right? You have to set a bunch of values here. So it'd be nicer if we could go use a constructor, a parameterized constructor, if you like technical terms. It's a fun one to say too, parameterized constructor. Just say it like 3 times fast. Parameterized constructor, Okay, no one else said it with me, and I was all by myself. That was sad. So a parameterized constructor is a constructor that takes parameters. You can also make no argument constructors. So right now we get a no argument constructor. It was being called by default. You get one implicitly. The values you get by no argument constructors are garbage. So if I put this in debug mode, please tell me you use debug mode at least once. No, okay, all right. Okay, debug mode. It's fantastic because it will pause your program and you can see the value of your variables. This is the most helpful thing you can do when figuring out why your program doesn't work, because it will pause and you can see what the value is before it does a weird thing with a weird value. It's fantastic. So come over to the gray space here next to your line numbers and put a click and it adds a red dot. That's called a breakpoint. When it gets to this line of code, wow, I'm going to spit at you, I'm sorry. I'm just that excited. It will pause. Right? So this is debug. So when I hit run, it runs with debugger by default. You can pick the run without debugger if you want. It's slightly faster. You've saved like maybe a second. Congratulations. If you do it 100 times, saving 100 seconds is actually halfway decent. So it's not the worst thing in the world, but go for it. So in debug mode, when my chair gets created here, it will pause at this line. Now I get the yellow arrow. So the yellow arrow is this line is about to run. Okay, and now I've got a couple different options here in my debug menu. I can step into my code, I can step over my code, or I can step out of my code. Depending on what we're doing, we're either going to step over, into, or out of. So into goes into functions, out of goes out of functions, and over just runs that line. So when I step over and run this line of code here, now I'll see Eric's chair as a variable. Sorry, I can't zoom this one in here. They're getting better at accessibility. But this debug window is actually really difficult. It was big news when they made it able for screen readers to be able to use this here. There's actually a rather well-known blind developer who works in their AI division, who they shamelessly had him promote their new accessibility tools. He's a really cool guy, does some really cool stuff as a developer in the AI space. But he gave a demo of like, look how amazing this is now. My screen reader works for debugging. And was actually really useful for that sort of thing. But you can see color is blank. So strings by default are just blank. That actually works out nice. They're not null, which is helpful because null stuff crashes our programs and null is sad. But my height in meters is garbage. Negative 0.9 something e to the 60, like some garbage value. This is not useful here. So your implicit default constructors give you garbage. It's usually not what we want. And now has wheels is true. Started off as true. Okay. I don't know if it's supposed to be true or not, right? Who knows? So as I step over my code now, or I can step into if I want. So stepping into will go into the set color function. If I step into, now we'll see, hey, I'm at the set color function here. Now the other variables went away. I don't have Eric's chair. It doesn't exist. I have a this variable now because in this function, this is what is referenced. This is Eric's chair, essentially. It doesn't work quite yet, but once you step into the function, then you can actually see the values. So if it looks like a bunch of question marks, just give it one more step, and you're good to go. So now I'll see the color attribute was blue. The color argument is blue. The color attribute is blank until this line of code runs, and now I can step over. Now I'll see this color is blue again. I set it to blue. Right? This is what we expect to have happen. We see it in the debugger. And then over on the right-hand side, we see the call stack. This is sort of interesting. Yeah?
Why, when you stepped into, did it jump up from line 30, like 30 something, back to 16?
So, yeah, so it went to the code that was running set color. So if set color was at line 100, it would jump to line 100. Okay. If it was in a different file, it would jump to the other file. It just goes to that location. Yep. Yeah, so yeah, it came from line 54. So this right-hand side, this call stack, is how C++ knows where to go. So it said, hey, I came from line 54. I went to, now I'm currently at line 16. It has to know what function was called where and when. And if your function calls another function that calls another function that calls another function that calls another function, you'll have 5, 6, 7, 8, 9, 10, 15, 100 calls in the call stack. Because it needs to know when it's done with that one, go back to the next one. When it's done with that one, go back to the next one. When it's done with that one, go back to the next one. It tracks all of that in this call stack, which is super cool. So you can see where it is here. And you can actually like go between, going between them is not very interesting, but all right, so this one's about done, right? We're ready to run line 16, which is done. Nothing else happens here. And then we jump back. We were at line 53, now we're at line 54. And if we step into this one, now we'll step into the set has wheels. Right? We can run set has wheels. Again, we are this now. It's not actually going to change anything because true is still true. But now we've set it to true. We've explicitly set it to true instead of taking that garbage value here. And you can go through and step. If you just step over, so if I open up Eric's chair and look at these values and I step over, things that change turn red. As the little visual cue here, it changed. And notice I tried to set it to 0.7, but I got 0.699999999999996. C++ is actually really bad at floating point values. It's rather difficult for computers to do these well. If you want to know why, go talk to the people in electrical and computer engineering. They understand this sort of stuff. It's a hard thing. But yeah, floating point numbers are hard, right? That's all we need to know about. So I don't recommend you do banking with doubles, right? The banking software uses specific actual classes that make sure we don't lose decimal places of things, because losing fractions of people's pennies upsets people. Not all that often, but you lose enough fractions of pennies, you lose real pennies. And eventually there's a movie about this called Office Space. You're probably all too young to have seen and appreciate. Oh man, such a good movie. Such a good movie. After you've gone out and worked for a while, it'll be much more entertaining. If you haven't spent any time in the workplace, it's not very interesting, it's just depressing. But after you've had some time in that world, you can laugh at it and be amused by it. So you'll get there. They stole a bunch of money by trying to take fractions of pennies. Okay, anyway. So there's chairs. So we can run through debugger if we want. So the default constructor, not great. Generally, you don't want that. Right? It's fine. We're not doing anything interesting. It's okay. But you generally want to write your own constructors. So to write a constructor, we write a special function. What's special about it is it doesn't have a return type. So I just say, hey, here's chair. So this now is a default constructor. Default or no argument constructor. Right? So this one now I can specify a constructor's job is to give values to your attributes. That's its job. So when the constructor's done, all of your attributes should have values. For a default one, they should have default values. Right? So sure. So I can say, hey, color is equal to an empty string. That's fine. I can say height in meters is 0. We can say my has wheels. I might actually set that one to false because I feel like that's a better default here than true, but it doesn't really matter much one way or the other. So now I have a default constructor. Okay? When I make a new chair, I will get these values instead of garbage values. It's always better, right? Garbage is never good unless you're a raccoon. We're not raccoons, right? Okay. The trash pandas. That's my favorite nickname for them. Okay. I actually have raccoons that live under my deck in my back of my house, which is a little bit irritating. But they're really cute. They show up on my Ring camera all the time. And there's like a baby raccoon that came up on the deck, and he's like pawing. It was really, they have like cute little hands. It's really neat. Anyway, so now when our code runs here, we'll run this in debug mode. I can step into my constructor, and we go to the default constructor. Before I had a default constructor, there was nothing to step into. The code didn't exist. It just happened implicitly. But now I can step into my default constructor, and I can see, hey, now Eric's chair will have these values of blank, 0, and false. Now I can go and set them. Again, we haven't really saved any time yet because I still have to call set. Now what I could do is have a parameterized constructor. You don't have to have a default one if you only want a parameterized one. Perfectly optional. Whatever you like to have, you write. Whatever makes sense for solving your problem here. So we can have another function for chair that takes a string for color. It takes a double for height in meters, and it takes a Boolean for has wheels. Right? You can have multiple arguments, right? You just comma separate. Nothing new here, I really hope. This is way back to functions. Okay? So now you can give it a color, you can give it a height, you can give it a has wheels when you call the constructor. Save some time. You don't have to call set, which is great. So now I can say my this color equals the color, or really at this point here, I can just call set color. Given the color, right? I can call set height in meters, given the height in meters. And this is especially good because I have logic in set height in meters that sanity checks and does the bounds checking for me. I don't want to have the same code twice, right? If you had me before, you're tired of hearing it, but if you haven't heard it before, if you have the same code twice, you should feel bad about yourself. It's a good rule of thumb, right? Because you could do it better, so feel bad about yourself and fix it. So don't have the same code twice. So if you have a set method that does your bounds checking, use the set method, right? Makes life a lot easier for us here. And the set has wheels is has wheels. Okay, so my parameterized constructor, such a fun word here, parameterized parameterized constructor, accepts some parameters, and sets the values to these. The constructor's job is to set the value of all your attributes. I'm setting the value of all my attributes, right? But now to make a chair, so if I want to maybe in Jeb's chair, I can say, hey, let's make this red a height of 0.5, and let's say his has no wheels here, right? Then I don't need to go and call all these individual set methods here, right? I can go and we'll set them all here. Double clicking will highlight an entire word for you. And when it hits dots, it stops because it's not an entire word. So Control C for copy, Control V for paste. I'll try and explain my shortcuts the first couple times at least, right? It's just a faster way of setting these things here. So don't type a bunch of things, right? Do less work, okay? It's better for you. False and 0.5. So you could call all the sets here, probably lowercase r, right, to make it match. Or you could use the parameterized constructor. At the end of this line of code, or the end of using a default and then 3 sets, you'll have the same thing. This is just now a different way of using your code. Parameterized constructors are a little bit easier, a little bit faster, right? The next really cool thing you can do with these is you can set, here, you can essentially make attributes read-only, okay? So I don't know if this really works for chair, but we're gonna pretend that you don't know what paint is, okay? Can we do that? So we're going to pretend like you can't paint things. So if I don't have a set color function, Control E and then C for commenting, if you like commenting code, when you highlight it there, Control E, C for comment. So if I don't have a public function for set color, I can't go change the color of a chair. So for now, we'll just take that one out for a second here. But I can say, hey, Jeb's chair is red in the constructor. If there is no public function to change the color, it's now a read-only value. Right? The only way this gets changed, and actually, so now I can't use set color here either. Sorry, this has to be this color equals color. If the only place that it ever gets set is in the constructor, it's read-only. And you can actually mark these things as read-only. There's ways, or constants we can mark them as, right? Once their value is set, they never change. We can add a couple extra things to code. We'll look at that later. But we're saying once you set the color, it's not allowed to change. So for certain objects, for certain classes, if that fits the problem we're solving, having the constructor allows us to have that read-only feature, that read-only ability. When we're talking about like student records, your name can change. Your student ID number will not change. Right? So when we make classes that represent students, your ID number is likely constant. There is no way to take a current student and change their ID number because bad stuff will happen. Right? You want your ID number to be attached with your record to make sure all the classes you took follow. I think you want your class records to follow you. Yeah?
So at this point, just declare something as a constant?
It's essentially constant. There's a special keyword we use for it. I'm trying to remember where we put it here. That's the kind of thing I have to go look up. I don't have that on the top of my head. But
you'd also make the height constant too.
Yes, so there's like you can have constant values like static values, things for pi or e or all sorts of fun math values. We can have constants for that, but so it's not exactly constant because it's not compile time constant. But the idea of you set it once and it never changes. That's the idea that it is a constant value throughout. So I think the keyword's a little bit different. I'll have to go look that up for you. But now I can't paint my chair. Essentially, is what we've said here now. Now we know in the real world you can go reupholster chairs, you can just throw some paint on, you can spray paint things, but just for the sake of illustration here, right? We're going to say you don't change the color. Okay, so now we have these read-only values essentially. So that's the other reason why having values in the constructor is nice, having a parameterized constructor. So if you shouldn't change these things, you set them once when you make the object, and then they're fixed forever. Right? So it adds to our toolkit of things that we can do here if we have those, which is really nice. Okay. All right. So now we've got parameterized constructors. We've got default constructors. Other weird things you can do with code. Right? I can make one chair equal another chair. Right? So I can say, hey, really, I want Jeb's chair to be equal to Eric's chair. Right? We can do that. Right? One chair equals another chair. Right, so this one's kind of fun. So let's actually go make another function here, just for fun here. When you have objects, right, you can use that type as now a variable, or as the type for arguments and functions. So if you wanted to print all of the chair details here, we can have a void function here for print chair details. This is super boring here, but you can have a chair. We'll just call it chair. And then we can see out chair dot get color, right? So whatever chair you give it here is some kind of chair somewhere in memory. I can use the get color method on it, the get color function on it, right? I don't need to know if it's Eric's chair or Jeb's chair or your chair or my chair. It's whatever chair you give it, we'll just call chair here. And we can see out these things. And line, and maybe we add, we can make this look pretty. Color is this, and then we get our color. We can have a height in meters, and a has wheels. Right, and we just change these to get has wheels and get height in meters. I don't have a get height in meters. Oops, we didn't write it. Okay, so we need a double get height in meters. Meters returns our height in meters. Okay, there we go. Now I can use my get height in meters. All right, so to print the chair details, let's go in. Before we do this, here we'll print chair details for Eric's chair, and then we'll print chair details for Jeb's chair, and then we'll set Jeb's chair equal to Eric's chair, bless you, and we'll print the chair details for Eric's chair, we'll print the chair details for Jeb's chair, and then we'll go change some things here in a second, but we want to print out the details, right? We'll just use that function. Not the most interesting function, but again, we can pass classes, we can pass references to classes, objects, right? An object is an instance of a class, that's our technical term here, for this around. So you make some chairs. I don't need the breakpoints, so I'm going to take those off and hit continue, so it'll keep running here. Continue. And we get no color, 0.7, has wheels is 1, true is 1, false is 0. Right? It's just stored as a single bit, on or off, which is fun. And then Jeb's chair is red, Eric's chair again, and now Jeb's chair equals Eric's chair. Right? So we get Eric's chair details again. Right? So I think that worked out. Cool. So we saw that. So we're able to set one chair equal to another chair. Now let's go and say, hey, Eric's chair dot set height in meters. We'll say this chair is adjustable here. We'll put it up to 1. And we'll print the details for Eric and Jeb's chair again. So when we set the height to 1 for Eric's chair, we print out Eric's chair. It's 1. When we set the height for Eric's chair to 1, Jeb's chair doesn't change. When we assigned Jeb's chair equals Eric's chair, I don't have two variables pointed to the same location in memory. When we start dealing with pointers, crazy things will happen. We'll get there in just a little bit, right? But for now, we've essentially gotten a copy of these things moved over into Jeb's chair. So we've assigned the values from one to another. And this actually gets to be a little bit complex, especially when we start dealing with things that use dynamic memory. When we start dealing with pointers, we run into all sorts of fun things here. So we're going to get there. We just haven't quite yet here. So if we take a look at the Zybooks here. No, that's the wrong one here, sorry. Zybooks. I haven't my URL isn't up to date yet here. So we look at objects and classes here. We look at, is it not in here? Constructors. Goodness, it's not there. What chapter? Did they move it? I'll find it for you. There's a place where we're going to use these. The copy assignment operator. Okay, I'm jumping too far ahead, forgetting where this is. So when we set something to another, we'll get into this into the chapter here, weird stuff will happen, but you can essentially add an operator overload for what should happen here to specify this is how we want to deal with this. Because when we start dealing with memory management, it gets to be important when I make copies of things by assigning one thing to another. So we'll get to those a little bit later. That's all. That's section 8, right? So we'll get into that in the next week or two. So this will be part of the first project, right? When we get into our project 0, we'll be dealing with all the fun stuff that comes with objects and classes, exceptions, dealing with pointers, and then these fun things that we get into for these ones here. So we get into the copy constructors, copy assignment operators, destructors, all sorts of fun stuff. The idea is it's the rule of 3. And we'll talk more about that when we get there. We're running a little short on time to get far into that right now. I want to make sure we finish out chapter 6 as well. So I think we're doing pretty good. So next week, Tuesday, we'll talk about the Unix lab, because I need to demo a couple things about Unix, show you how to do it, because it's it's an experience. You'll be glad you've done it. You can talk about it, and you can laugh at everyone's jokes about how you exit VI or Vim. That's great. Then we'll talk more about objects and classes, get into some more of this advanced stuff. We've got more things happening here, which is lots of fun. Operator overloading is really interesting when we get into that. Comparison operators is fun. How do I compare one chair to another chair, which is greater, which is less than? How do I add two chairs together? When you can like stack two chairs on top of each other, I guess. I wouldn't recommend you sit on it, but you could if you wanted. And then we'll talk more about static data members and functions as well. So this idea that everything we've done so far is an instance of an object. When we talk about static, it is a single value that belongs to the definition of the class, not the instances of the class. And it gets to its own fun troubles there as well. And then we'll talk about unit testing. This is another fun topic. I like using the unit test library because it's good and makes my life easier. And then we can hook up all sorts of fun things. We'll talk about continuous integration testing and continuous deployment for software. Really fun stuff. I'm trying to get you excited for next week. I know the topics can be a little dull sometimes, so giving you a taste of what's to come is, I know you're just very super excited now and not tired because I've been talking at you for more than an hour writing code. All right, cool. So we'll call it a day. I'll post this out. If you got questions, let me know. I'll be hanging out after class. I'm going to head over to the CIS building if you want to chat. And then, yeah, was it a question? Or? Yeah, so that's right. So I can go and commit now. So you'll notice this is yellow. Everything in green is new. Everything in red was removed. It's like, oh, hey, int main is now at was at line 4. It's now at line 74. You got rid of this one here. You added a bunch of stuff, right? So here's my chair class. We'll commit and push that. Thank you. Yep. All right. I will see you folks on Tuesday then.